Hello everyone, this is going to be the first video and hopefully a series of videos where I solve interesting problems and give you guys my solution to them, and hopefully you'll learn something along the way. So this problem comes from a recent video of Michael Penn. I'll link his video into the description. He's a great math YouTuber who solves really great problems, and I wanted to give you one of his from an Argentinian Olympiad. So how it goes is it asks for this equation where we have x in real numbers, where we have the floor of 2x plus the floor of 3x plus the floor of 7x equals 2008. So there's a couple of ways you can approach this. The way I would like to approach this is thinking back onto the real numbers. So the real numbers have kind of two parts to them. The real numbers have, let's say we're thinking about this kind of arbitrary number. They have this part and they have the decimal part. So I'm going to kind of divide our real number x into two parts. This integer part plus this decimal part. And when I do this, we'll see that our equation actually becomes much easier. And I'm going to have even a little bit of a trick for this fractional part right here, this decimal part. What I'm going to say is our decimal part has to fall somewhere in the interval of 0 to 1. And note that we're not including 1, because if we did, then that would actually increase n by 1. So what I'm actually going to do is I'm going to write x equals n plus d over 42, where d is in the interval 0 to 42. And the reason I do this is because 42 is actually the least common multiple of 2, 3, and 7. We'll see why that becomes helpful later. So this is how we continue. We notice when we take the floor of some real number, all we're getting is just this integer part. So immediately what we can do is we can look and we say, here we're going to get 2n, here we're going to get 3n, here we're going to get 7n. Now the problem comes is when this decimal part, when multiplied by any of these numbers, happens to go over 1 and then is included. So we'll account for that. So when we add these together, we're going to get 12n. So let's rewrite our equation. We get 12n plus the floor of 2 times our fractional part, d over 21, plus 3 times it, d over 14, plus 7 times it, d over 6, now equals 2008. And at this point, we can do a really nice trick. So the way we continue with this problem is looking at just n. So we note, we try to find the point when n will surpass 2008. So we try to solve the equation where 12n is going to be less than or equal to 2008. And we find that this actually happens at n is less than or equal to 167, where 12 times 167 ends up being around 2004. What we notice is that, well, if we increase this number by a little bit, and we can account for that in here, we'll get to 2008. If we go over, if n was 168, we would be past 2008. But we also notice if n was 166, well then we would already have 1992. But to get to 2008, that's going to take 16 more. And this floor function is not going to get you 16 ever. Actually, you can check that the maximum of this is 11. Or actually, I think it's 9. But nonetheless, it's going to be under 18. Or whatever the other number was, 16. So to continue, all we have to do is we have to, now we know that n is 167, which is really important. So now that we know n is 167, we can actually plug it into our equation. If n is 167, then all we get is that this floor function, floor of d over 21, plus the floor of d over 14, plus the floor of d over 6, is actually just going to be 2008 minus 2004 equals 4. So now all we have to do is solve this equation. And this ends up being pretty easy, since these floor functions are going to do really all the hard work for us, and the fact that we use this trick of d over 42 for the LCM is going to be really nice. So we note when d is 6, this is only 1. It becomes 1 because this is going to be 0, this is going to be 0, this is going to be 1. When d is 12, a similar story, it's going to be 2. When d is 14, something slightly different occurs. When d is 14, we get 2 out of this, d over 6, and we get an extra 1 from here. So now we're going to have 3. And the first time we hit 4 is when d equals 18. And this is because 18 over 6 is 3, and this 18 over 4 is going to be 1 plus some decimal part, which is going to floor down to 1. So we find for d greater than or equal to 18, this is going to work. But if we go too far, then the equation might be greater than 4. So let's find when that happens. That's going to first happen when d is actually equal to 21. This happens because we're still going to get 3 from the 6, 1 from this 14, but we're going to get an extra 1 from this d over 21 for the first time. And now this equation is going to output 5. So we know d is greater than or equal to 18, and we also know d has to be less than 21. So now we've basically solved our problem for some interval of numbers. What we solved for is x equals 167, this is from our n, plus d over 42, where d is in this interval of 18 to 21. And we can do some simplifications to make this look nice. 18 over 42 is actually just 3 over 7. And 21 over 42 is actually just 1/2. So 167 plus 3/7 all the way to 167 plus 1/2. And that is the answer.